Alright, welcome back EDP students. In this video, we're going to look at switches. So, we've seen that we have a microcontroller, and we saw last week our digital pins. Now, last week we used our digital pins as outputs, and we're able to flash an LED. In this week, we're going to look at digital pins as inputs. So I'm going to choose a digital pin here, and I'm going to connect a piece of wire to it. Now you'll notice that there's a gap in the middle, and then it's connected to ground, or 0 volts. I'm then going to add this. Now this is a push button switch. So the push button switch can go down, or up, or down, or up, or down, or up. Okay, so when I push it, it goes down. When I release it, it goes back up. Now, when I push it down, on the input, I should get 0 volts, or a low. And that's because it's now connected to our ground, or 0 volts, or low. Okay? Now, when we release this switch, we have a lower here, but what do we have on the digital pin? It's not going to VCC, it's just floating. Okay, so this isn't very good because we don't actually know what the input is. Okay, we've just got a floating piece of wire. So it could sometimes be low, it sometimes could be high, it could be anything. So what we do to overcome this is we add a resistor and then connect it to our high value, which is 3.3 volts for our case. So what this does is what we're reading right now is 3.3 volts. Okay? And the reason for this is that current will always take the path of least resistance. So we can see that there's no path here, okay, because the switch is open, but we can see that there's a path from the 3.3 to our digital pin. And so if we read this, we'll get a high. Okay? Now this resistor here that we've got is called a pull-up resistor. So when it's disconnected, it will always give us 3.3 volts. Alternatively, we could have a pull-down resistor, which would go to ground, so when it's disconnected, it will always be ground. Now, when I close my switch this time, I get a low on my digital pin, and that's because there is no resistance between here and ground. And as we said, current will always take the path of least resistance, and this has 10,000 ohms versus this which has 0 ohms, and so our path of least resistance is here, and so we get 0 volts on our digital pin. Alright, so that's it for this video. In the next video we'll look at how to code this and how to connect this on our breadboard. Thank you.